Unit 3 Chemistry, Chapter 3, Part 3, Gas Stoichiometry. So just as we can do stoichiometry between two solutions, where we would use the amount in mole as the concentration of the volume to find the amount in mole and then use our ratio in our equation, or we can do it between two things that we know the mass, using N equals mass over molar mass. We can also, now that we know how to use volume to find mole, do stoichiometry with gases. I know you're all very excited by this. Okay? So, if we wanted to start with a mass and we wanted to find the amount in mole, or vice versa, as with all stoichiometry, we would start by writing the full balanced equation. Okay? Then, if we're given a mass, we convert that to mole, using N is mass over molar mass. We then convert the moles of what we know to our unknown using our molar ratio in the equation. And then we convert the moles into the volume. Well, in this question, if we were thinking about something at STP, then we would use 22.4. We might use 24.5 if we're at SLC. We might use our ideal gas equation. Okay? So, if we want to know how much hydrogen gas is produced by reacting 27 grams of aluminium with excess hydrochloric acid. So excess, remember, that means we've got more than we need. Here's our balanced equation. It's a bit of a complex one. We've got slightly complex ratios. We've got to make sure it's balanced before we do anything else. Then we're going to use amount is mass over molar mass. So we'll find the amount in mole of aluminium, which is basically equal to 1. We know that 2 moles of aluminium gives us 3 moles of hydrogen gas. So we do what some people say is want over got. What you want goes on the top, what you've got goes on the bottom. So want over got, times it by 3 over 2. So we get basically 1.5 moles of hydrogen gas. Okay. We said on the previous page that this was going to be at STP, so we're going to use our molar volume. We could use ideal gas law, but it's a lot more complicated, and why would you use a more complicated one? So we're going to multiply it by the molar volume at STP, which is 22.4, and that will tell us that we've got 34 litres to 2 sig figs. Why 2 sig figs? Well, look back at my question. My mass is to 2 sig figs, so my final answer has to be 2 sig figs. But I didn't round it throughout. Okay, I keep that full number until I get to the very end. I can also do volume stoichiometry. Now you'll like volume stoichiometry because it's got many less steps. Remember that if the conditions don't change, the volume of any gas is proportional to the amount in mole. Yeah? So if I've got 1 mole of my reactants and 1 mole of my products and my temperature and pressure didn't change, then they're going to occupy the same volume. Which means if I've got a balanced equation, I can just use the ratios in that equation without converting to mole. I know, I said you were going to like it. So the 2 steps. Firstly, I write the full balanced equation. Then I use the conversion factor, which you may know as your coefficients, okay, to find my unknown. Okay. So what volume of oxygen should be used to fully react 1.5 litres of hydrogen gas to make water? So I've got a 2-to-1 ratio in my full balanced equation, which is the first thing that I do. 2 mole of hydrogen gas needs 1 mole of oxygen. So I'm just going to use these ratios. I'm not converting into mole because we are not changing the conditions because they're both reactants. So of course they're both at the same temperature and of course they're both in the same pressure because they're reacting in the same vessel. Okay. So, want over got, so we are multiplying by 1 over 2, because I want 1 mole, and I've got 2, so I'm basically halving it. So I need 0.75 litres of oxygen to fully react it. And that's it. That's the only step you need to do. But be aware, this little cheat only works if the conditions don't change. If the question says the temperature changes or the question says the pressure changes, then you've got to go back to using your molar volume or your ideal gas law.